Hello, everyone. Today's question is, what is the ij variable denoting in the test for lack of fit equation? The textbook states, let yij denote the response for the jth observation at the ith level of the independent variable, but I'm not sure exactly what that means. I think an example in this case might help. So suppose we have this data x and y that has 20, 20, 20, 40, 40, 40, 60, 60, 60. So I is going to note the number of levels in the independent variable. I could range from 1 up to the number of levels. So in this case, we have 3 levels of x. We have 20, we have 40, and we have 60. That makes 3 levels. So I ranges from 1 to 3 in this case. And J is going to go from 1 to Ni. So this is the number of observations for group I. Now, in this case, each of the Ni's equals 3 because there's 3 observations within each group. So essentially, we can think of these Y's being denoted by the ith level of the independent variable and the jth observation. So example, 86 would be y11. 80 would be y12. 77 would be y13. 78, now we're in the second group. This is y21. 84, y22. 75, y23. Now we're in the third group. We're in the third level. So 33 would be y31, 38 would be y32, and 43 would be y33. So the I is telling you which group you're in, group 1, group 2, or group 3. And the J is telling you which observation within the group you are. So here, walking through it once again, just this first 20 would be x11, x12, x13. The 40 would be x21, x22, x23. And then the 60s would be x31, x32, x33. So essentially, these are just denoting which level of x are you in? That's the I. And then the J tells you which observation are you at? Are you the first observation, the second, or the third? Okay, y bar I is the group mean for group I. So if you average 86, 80, and 77, you get y bar 1, 81. If you average 78, 84, and 75, that's y bar 2. The average of group 2, 79. If you average 33, 38, and 43, that's y bar 3. That gives you 38. Now I'm going to break down this piece, the contribution to pure experimental error, by taking every observation, subtracting the mean. So we get 86 minus 81, 80 minus 81, 77 minus 81, 78 minus 79, 84 minus 79, 75 minus 79, 33 minus 38, 38 minus 38, 43 minus 38. That's where you get your 5, -1, -4, -1, 5, -4, -5, 0, 5. From there, we can square each of those values. 5 squared is 25, -1 squared is 1, -4 squared, 16. -1 squared, 1, 5 squared, 25, -4 squared, 16. -5 squared, 25, 0 squared, 0, 5 squared, 25. Then we're going to sum up each of those groups. 25 plus 1 plus 16 makes 42. 1 plus 25 plus 16 makes 42. 25 plus 0 plus 25 makes 50. At the end of the day, we need to sum up each of those values. 42 plus 42 plus 50 makes 134. So from there, we have our SSP of EXP, and we get 134. And from the table, you got the sum of squares of residuals being 894.5. And so you can calculate your sum of squares lack being sum of squares residuals minus SSP EXP, and we get 760.5.